In this video, you are going to see some data about steelmaking and a brief introduction to blast furnace and direct reduced iron processes. Now, let's have a look at some useful figures regarding steelmaking and CO2 emission. All figures are collected from a Google search. Number 1, current concentration of CO2 in atmosphere is 421 ppm. It has increased by 50% from 280 ppm mid of 18th century due to industrial revolution. Number 2, 89% of total CO2 emissions in the world is due to fossil fuel burning. Number 3, 11% of the world's total CO2 emission comes from land use change. Number 4, 0.04% of atmosphere is CO2. Number 5, total steel production globally is 1.9 billion tons in year 2022. Number 6, total CO2 emitted by steel production globally is 1.9 times 2.7, which is equal to 5.13 billion tons in year 2022. Number 7, 11% of total CO2 emitted in atmosphere comes from steel production. Number 8, one normal car produces 1 ton of CO2 in 90 days. Number 9, 1 ton of CO2 gives 270 kilograms of carbon. Number 10, CO2 due to steel production is 11% of total CO2 globally. Number 11, 70% of all produced steel in the world is by BF, which stands for blast furnace, or BOF, which stands for basic oxygen furnace. Number 12, 37.15 billion of CO2 is emitted in year 2022. This is equal to 101.8 million tons daily. Number 13, cars and vans produced 48% of CO2 in year 2022. Number 14, in year 2022, DRI global output increased by 6.9%, which is up to 127.36 million tons. Percent of iron produced by DRI method is equal to 127.36 million tons divided by 1.9 billion tons times 100, which is equal to 6.68%. Steel production has a number of impacts on the environment, including air emissions like carbon monoxide, sulfur oxide, nitrogen oxide, and PM2. PM2 stands for fine particulate matters with less than 2.5 micron diameter. Wastewater, contaminants, hazardous waste, and solid waste. The major environmental impact from integrated steel mills are from coking and iron making, which are two different parts of a steelmaking plant. The Middle East and Asia are the largest producers of DRI, 54.8 million tons and 39.5 million tons, respectively. In 2021, the world production of direct reduction iron increased by 13.7% compared to 2022, up to 119.2 million tons. In this picture, you see the curves for DRI production by different processes, Midrex, HYL, or coal. This blue one is for Midrex process. This brown one is HYL1, HYL3, and this black one is for direct reduction by coal. And this violet one is the summation of all these. As you see, production of direct reduced iron is increasing by year, going up and up. Now let's talk a little bit about the blast furnace operation. As you see, we have a blast furnace here. Body of the blast furnace is steel. We have a layer of coating inside, everywhere inside, to protect the body of the blast furnace from getting hot and melt down. We have iron ore as sinter and coke and lime, everything we carry here on the top and charge the furnace from the top and we put them inside the furnace. Here we have an air blower. We blow air here, some stoves here. They warm up and heat the air, and the hot air is going to be injected in bottom of the blast furnace. And in furnace, the coke is going to be fired and get red and produce CO, and iron oxides are going to be reduced by the CO. On top, we have some top gas, we have some waste gas, we collect them, we cool them, we separate some dust and water vapor and things like that, and the rest, which contains CO2, CO, and maybe things like that, we inject here some enriched gas, which is methane gas, CH4, and we bring them back and we use them as the fuel to burn the burners here in the stove. And finally, as you see, we have a chimney here. The CO2 produced by burning finally goes into the air. Here we have a gas holder for times that the gas line is going to be off. We put some gas here. We have a tank here, and this is the simple explanation of a furnace, of a blast furnace. This pass, the CO2 comes here, and we again use it as the burning fuel, and finally CO2 produced goes to the atmosphere. Is common between degradation plants and this blast furnace plant. This is a figure of the blast furnace itself. You can see different temperatures here. Note the temperature 1500 degrees C here, 850 degrees C here, 250 degrees C here, and the molten iron is here, and this is the formula for reduction. Of course, we have FeO and other types of oxide here, which is not mentioned here. This is the main formula for reduction, and some other formulas here, and this is all about this figure. Blast furnace operation and its ancillary processes contribute the largest amount of CO2 per ton of steel production due to use of coal and coke. DRI processes, which are based on natural gas, produce less than half of the CO2 emissions of a blast furnace. Let's talk about the Midrex process. This is the flow diagram. We have a shaft furnace. From the top, we charge the furnace with iron pellets. From here, we inject hot reducing gas, which mainly contains of CO and H2. This hot reducing gas, about 1000 degrees, 980 degrees, is going to react with Fe2O3 and produce H2O and CO2 for us. Top of the furnace, we have top gas, outlet gas. We cool it in a scrubber, and then we pass it through a compressor, process gas compressor. And part of the top gas after cooling is going to be mixed with natural gas here, and with some gas that comes with some air that comes from the air blower here, and together they provide combustion gas for us and goes to the burners to burn and produce heat for the pipes inside the reformer. This is the reformer. Okay, the main part of the top gas of the compressor comes here. We inject natural gas here. We pass it through the preheater, pass it through the preheater, and it is going to be called feed gas, and they are injected in the pipes in the reformer, and in the reformer we have catalyst, and at the output of these pipes we are going to have reducing hot gas. As I explained, we inject it here. So the reformer, as I told you, it has many burners. The burn gas contains lots of CO2 and it's hot. Before sending this hot CO2 to chimney, we use it to preheat this process gas here, as I told you, and the air produced by the main burner, the air burner, which is used for the combustion gas here. Okay, here we are going to have a sponge iron, which is hot. We should cool it before reaching the outlet here, bottom of the furnace. So we take some part of the gas here, pass it through a scrubber, cooling gas scrubber, and cooling gas compressor. We cool the pellets here, and cooling the sponge iron here, and it goes to the output of the furnace as the reduced iron. This is the brief explanation of this process. If you are going to have hot discharge, not cold sponge iron, hot discharge, we omit these parts here. We have this version, and we use this hot sponge iron, and we send them to the steel making plant, as I explained in next figure. So in this diagram is a Midrex plant with discharge options. We have options here. You see, not only the cold sponge iron, but also we can have discharge. We can have hot transport. It means that as the sponge iron is hot, we can take it to the other parts of the factory, and it is called hot transport. Everything is the same, except that we don't have this cooling system here, as I explained in the last explanation for cold discharge.